So we've learned how to predict the products for precipitation reactions, for acid-base reactions, for gas evolution reactions, and for certain combustion reactions. In addition to that, if I give you an equation, you need to be able to tell me what kind of a reaction it is. So there's two different ways of classifying chemical reactions. One is by looking at what happens. So a precipitation reaction, a solid is forming. That's a precipitation reaction. Acid-base reactions. We've got an acid and a base reacting. They're neutralizing each other. Gas evolution reactions. These may be acid-base reactions as well, but we see that we have two aqueous solutions and a gas is formed. That's it. Gas evolution. And then we've got the oxidation reduction reactions where electrons are being transferred. We recognize these as anything reacting with elemental oxygen, a metal with a nonmetal, or some evidence of electrons being transferred. Combustion reactions are a subcategory of that. Those are the things reacting with oxygen. So that's one way to categorize or classify chemical reactions. The other is by looking at what the atoms are doing. So we can have a synthesis or combination reaction. Here we have two things. We're just using these letters to represent elements and compounds. A plus B, and they're combining to form one thing. So two things combining is a combination reaction. We can have a decomposition reaction where you have one reactant and it breaks into two pieces. That's a decomposition reaction. So those are kind of opposites of each other. We can have displacement and double displacement. So we have seen these double displacement reactions as acid-base reactions and precipitation reactions where the partners are switching places. Here A and C are the guys and B and D are the girls, and they're swapping partners. They came to the party and they left with somebody else. The displacement, which is sometimes called a single displacement, here's where guy A went to the party by himself. And then you have this couple, guy B and girl C. And they go to the party, and C finds guy A a lot more attractive than the guy she came with, and so she goes home with him, and B goes home by himself. It could happen, right? So that's a different way of categorizing equations. So let's talk about those again. I already talked about them, but so we've got simpler substances in the synthesis or combination, simpler things making something that's more complex. You have one product. The example is sodium and chlorine reacting to form sodium chloride. You have two reactants, one product. Synthesis or combination reaction. Decomposition is the opposite. One reactant forming two or more products. The water is being decomposed by the electricity in the battery. Single displacement, you have one element displacing another. So here, zinc is kicking copper out of this compound. So zinc leaves with chlorine and copper goes home by himself. Double displacement, you have two elements or groups of elements in two different compounds that are switching places. So A and C are changing places. So we end up with AD and CB. Lots of reactions fall into this category, and these are the ones that I want you to, for the most part, the ones that you need to be able to predict. And you predict the products just by swapping partners and seeing what happens. So precipitation reactions, acid-base reactions, gas evolution reactions fall into this category. So this is the other type of classifying by looking at what the atoms are doing. So let's practice this. Classify each of these as synthesis, decomposition, single displacement, or double displacement. You're given 4 choices. Some of these could also be classified as combustion or precipitation, but those aren't the choices we're given, so we have to pick from the choices. So this one, Al and H3PO4 going to AlPO4, that reminds me of dog food, and hydrogen. Single displacement. So here aluminum's coming in by himself, and he's displacing hydrogen. Hydrogen's leaving by himself, and now aluminum's leaving with phosphate. So that's a single displacement. Something like that. What about this one? Double displacement. Copper came with sulfate, copper's leaving with hydroxide. Potassium came with hydroxide and leaving with sulfate. They swapped partners. Double displacement. I'm just going to call that DD. I'm tired of writing all these letters. Double displacement. How about this one? So it kind of looks like a single displacement, but is anybody actually getting displaced? No, it's a synthesis. So, synthesis. And what about this one? Decomposition. So we have one reactant and it's coming apart, it's decomposing. It's like when you play Mozart backwards. It's decomposing. Any questions? Thank goodness.